All right, I'm so excited to show this to you. You don't even know. This makes things so much easier when you're trying to make a model hollow for 3D printing. It's also called shelling. So we've got this model here, and it's Edgar Allan Poe, and you can see it's a solid model. It doesn't have a hole in the base, but that's where I want to put a hole. There's a couple complications, especially the traditional way to go about doing this. There's a lot of things going on. For example, we've got a lot of different subtools. Okay, this is made up of a lot of different pieces. And so in the past, what you'd have to do is either hollow each one of these individually and then create a hole from one to the other so that a hollow space can pass all the way through the model. And that is so time consuming. Or what you'd have to do is dynamesh everything together, which is a very destructive process, and you lose all these layers, all these different subtools. And then what you could do is use panel loops to shell that surface. But then if you want to change something, you have to go back. Then you have to go all the way back to the version you saved. Hopefully you saved it before you dynameshed everything together. And then even if you use the panel loops to shell it, what will happen is in thin sections, like here on the lapels, on the collar here, or on little bits of hair like that, the internal surface will actually push through to the outside, and then you have to go through and clean that up manually. Now there's also shelling with Dynamesh. If you go into your geometry and you go into Dynamesh, there's create shell, but this thickness is very unpredictable and it actually doesn't relate to real world units. So then you don't get a very precise shell. So there's a lot of manual work, a lot of futzing with numbers and everything. So I went through and I made some macros that simplify this process so that you just don't even have to think about it. You just set the number that you want and boom, it's done. Okay, maybe not quite that simple, but it's a lot simpler than the previous methods. Okay, first thing you want to do is go down into the description of this video and you want to find a link, download that zip file. Inside that zip file, you're going to find some text files. So you want to just copy these, select them all, copy them, and then go into your Zbrush folder with your version number. And then you want to go into Z Startup. And you want to go into macros and MISC. You just want to paste that in there. Now I've got a whole bunch of custom macros. Don't worry about all these that you see here, but you just want to paste that in there. Then you want to go back into ZBrush, either open it, or if it's already open, you want to go to macro and reload all macros. Okay, so you can see here, this is all these. Try to ignore all of them except for these 8 right here, DynaShell. Okay, this is what you're going to click on to set the thickness. Now you need to know what unit of measurement you're working in and how thick you want it to be. Hopefully in the future I'm going to be able to make this so it's a slider so you can get exactly the number you want, but these are the thicknesses that I use most with 3D printing. So 0.04 inches is about 1 millimeter. 0.08 inches is about 2 millimeters. That's the thickness I use a lot for 3D printing with the full color sandstone material on Shapeways. That's the minimum wall thickness. It's actually slightly thicker than the minimum wall thickness, just in case there's any sort of inconsistencies. Then we've also got about 3 millimeters or 0.12 inches, 0.25 inches or quarter inch, you got a ½ inch. And then also, if you're working with millimeters, you might want a quarter of a millimeter, ½ a millimeter, 1 or 2 millimeters. Okay, so this is all great. Before we click on this, however, there's a little bit of prep work we got to do. What we need to do is work on a single combined model version of all of this. So what we want to do is make sure that all of our subtools that we want to be part of this 3D printed object are visible. And then let's go to merge and merge visible. So what this does is it makes a new tool of everything merged. The next thing we need to do is set a Dynamesh level for this. Now, it's a little bit of a guessing game of the exact Dynamesh level you should be setting. So let's play around with this a little bit. Let's set a resolution. Now, let's just set something really low to test it out first and click on Dynamesh. Depending on how big your object is, even the lowest resolution setting will be really intense. So we want to start low. Okay, so what we've got here is a little too low. You can see that it's kind of destroying some of the structural elements. So I'll just hit Control Z to undo that. Let's set this a bit higher. Let's try something like 90 and click Dynamesh. Okay, so what you can see here is that it's not preserving the fine details, but it is preserving the general shape of everything. So that's actually pretty good. All right, now let's copy this. So let's go into Subtool. Let's copy this subtool. Let's go back into our original file, and now let's paste that in. Okay, so now we've got this merged version, and now we can go and mask off where we want the escape hole to be. So for this, I want the entire bottom to be an opening. The escape hole, it can just all be open. Depending on the model you're working on, you could put it all kinds of different places. You could make multiple ones. It doesn't matter. Make as many as you want. This is going to work for this. Okay, now that we've got that in place, now we can go up to macro and let's set this. Right now my model, let's check actually how big this is. Let's go to geometry and we'll go to size, and you can see here the Y size, or the height, is about 4.8 inches. That is perfect. That's how tall I want to print it. So since we're working in inches, I want to make this 0.08 inches thick. So we'll come down to Dynashell 0.08 and just click on it. Now it's going to process for a couple seconds, and now you can see what it did is it took that object that we had Dynamesh before, and let's turn on solo mode just to see it all by itself. So you can see it's kind of a shrunk in version of the model. So this will be the internal surface. So what we can do now is turn solo back off here, and I'm actually going to go into transparent mode so we can kind of see this even more clearly. So the subtool that's currently active is what we're able to see, and then everything else is kind of a ghost version of it. So you can see the original model here through the ghosting. Let me try to get a good point where I can kind of measure the thickness here. Okay, so let's get our transpose tool, click and drag on this. If you're not getting this line, you want to make sure that the gizmo is turned off, or click Y. And let's just measure the thickness here of that. So you can see, if I hover over this, you can see up here in the top units, 0.08 and some change. Of course, this measurement isn't like 100% accurate. So you can see it gave us the correct thickness. All right, let's go back into draw mode. We can turn off transparency. And now what we can do is turn on the Boolean. So we got live Boolean. Actually, the macro turns this on for us. So all we have to do is turn that into subtraction mode. And you might want to make sure you've got a start group going here at the top. And then it'll just add everything together and then just subtract our subtraction surface here at the end. Okay, so you can see that this live Boolean is cutting this subtraction surface all the way through the model, all the way through everything. So that is really great. So to get this ready for printing, we can go into Boolean under Subtool and make Boolean Mesh. After a few seconds of processing, it should spit out a new tool. Okay, here we go, UMesh. And we click on this, you can see it's one solid subtool, and we've got that solid surface. If I turn on wireframe, you can see it fused the inner surface with the outer surface. And this is ready to export for 3D printing. We might want to decimate it first. It's about 1 million points, so that's actually 2 million polygons. So probably want to decimate it first, but that's another video, another time to get this ready for 3D printing. To just export it, it's actually not too hard, but now that we've got our thickness made, our hollow surface, this is ready to go. All right, thanks for watching. Please download it, enjoy. Leave me a message in the comments if you have any questions or problems with it, and remember to subscribe.